in University of Hyderabad. Madam published books and many journals. One of the books was Coefficient of Variation and Machine Learning Applications, which was published by CSE Press. Madam also published few journals. Multitask Learning for Toxic Comment Classification and Racial Extraction, and Attention-Based BLSTM Network for Abusive Language Detection are few of them. Madam also participated in many conferences, investigating the role of named entity recognition in question answering models, 2022 IEEE 3rd Global Conference in Bangalore, and proceedings of the International Conference on Cognitive and Intelligent Computing held at Singapore. Madam got selected for Scientist B position at DRDO in 1999. Madam also got reputed certifications from Coursera and Sun Microsystems. Madam is a member in ACM and IEEE and also a life member in Indian Society for Rough Sets and Society of Development of Statistics. Madam also have a lot of professional experience. Madam works as professor in Vishnu Institute of Technology, Bhimavaram, worked as professor and associate professor in Ramachandra College of Engineering, Eluru, worked as associate professor in Sri Vasavi Engineering College and CSE Institute of Technology, Tarepalligudem, worked as assistant professor in Sir C.R. Reddy College of Engineering
for their BTech final year course or MCA. Right? How many of you used it so far? Just raise your hand. Once at least. Okay. Can anybody narrate how is it different from a search engine like Google? We are habituated to Google for anything whenever we wish to know something, right? So, what's the difference between these two? Your faculty, right? So, MBA, yeah, they have the initiative quality that even other folks should learn, okay? So, an MBA faculty says that ChatGPT has AI inbuilt. How many of you agree with him? Just raise your hand, it's a small poll. Okay, a couple of them, fine. Do you think that AI means something that involves some robo, and how many have that kind of feeling? The moment people say AI, you get some images into your mind, some robo handling something, the famous Terminator movie, okay? Or our famous Robo and Robo 2.0. Okay, I contradict with him. ChatGPT alone is not powered by AI, even Google search is. AI is an umbrella term which encompasses even data analytics and NLP too. Okay? So, Google search engine does lot of indexing of the web pages, and then it runs an algorithm called PageRank, which ranks the web pages according to the search query given by you, and then retrieves the results. Traditionally, it used to retrieve only the web links. Nowadays, you find a summary of the answer as a small paragraph or 2-3 sentences, a small abstract of the summary, and then related questions and their related answers, right? This is all powered by some of the techniques that we talk today. And ChatGPT is also a prominent user of deep learning models for building natural language processing applications. Okay, the fundamental difference is when you question or query ChatGPT, the answer that you get is in the form of a descriptive document. Okay, it's just like somebody else is interacting with you. It's like conversational mode. The text that you receive as the search result is kind of automatically generated content, and the technology behind is something called as language models. And the fun fact is ChatGPT is outdated compared to Google. The reason is The language model that ChatGPT is built on is up to the knowledge available over the entire internet up to 2021. That means 2 years outdated. So the most recent things would not come in your results. So you have to use it with caution. Whereas with Google, I think the delay maybe for some topics few seconds, like the politics, sports news, and for some topics like research related things, maybe a couple of days, and for some things which are not so popular, it may be a couple of weeks or even months, not months, maybe 2 weeks or so. So it all depends on how quickly the spider program of Google indexes your data. If it is some politics, like let's say some Joe Biden did something, or some Dhoni or Kohli did something, it's very important, right? So you immediately get the feeds. So such kind of data is immediately updated. Okay? So with that prelude, let's get into this. How many of you can see it? I find many vacant seats here. Can you just come forward if at all you are interested? If you are not interested just to be there for the sake of being present, your body but mind absent, you can stay there because you cannot see what I am showing on the screen. Students, come forward. What's stopping you actually to come forward? I don't find anyone voluntarily raising up. Like somebody has to come and ask you to move forward. If somebody is forcibly making you to be here, then you can happily leave. Okay? If you are interested to learn something, then you be here. Can you see? Can you read the screen? The boy over there. The last boy over there. Can you just read the slide? What are the subtitles at least? Let's not waste our time. So, you can see that some of the applications that are mostly solved are listed on the left side. Like spam detection, it's very difficult for a day, in these days, to send a spam email to somebody. Okay? So, spam detection is almost solved. Part of speech tagging, given some sentence, telling for every word what is the part of speech, like whether it is a verb, noun or adjective, that is also almost solved, unless a language like our Indian languages for which such models are not built. For English it is solved, okay, and for some other popular languages also it is solved. And then named entity recognition, let's say you give a sentence and who is the person in this, okay, what phrases correspond to some location. Okay, like New York, okay, and some date. These are all called named entities, recognizing them, okay. And for all of them, the winners are deep learning models actually, okay. If you consider, I don't know for the students, but a little bit elderly faculty here, maybe 10 years ago, if you see the kind of search results that you are receiving through Google and the kind of search results that you receive today, you find lot of difference. Okay, you hardly find something that is not sensible to the query nowadays. So the performance of the search results have increased a lot because of lot of deep learning models that are built behind. Okay. So and the other applications which are making some good progress are sentiment analysis. Like you have an Amazon review and you wish to give the sentiment label for this, whether it is a positive sentiment or negative sentiment or neutral. It's not so easy like somebody saying I love this product, okay, or I hate this product. It's not so simple like that. People use some beautiful sarcasm and some idiomatic language, flowery language and other things when they write reviews. So it's not so easy just to look at some positive or negative words. It's still in progress. And then co-reference resolution, like here if I read the sentence for you, Carter told Mubarak he shouldn't run again. Here, to whom is this he referring to? Is it referring to Mubarak or is it referring to Carter? So you need to determine to whom it is referring to. Okay, that is called co-reference resolution. And then word sense disambiguation is looking at the word, in what sense is this word being used. Okay, when you see this example here, I need new batteries for my mouse. So obviously it is the computer mouse, not the biological mouse, right? So you should get the sense in which it is being used. So how do you do that? Mouse could be the computer mouse or the regular mice that we see in our homes. So how do you differentiate, how do you disambiguate them? For that you need context. How did you determine that it is the computer mouse? Because you said I need batteries. Why would a regular biological mouse need batteries, right? So that's how. So you need context. Remember this, we'll come back to the context again. And parsing, like all languages have some grammar, though it is not a strict grammar. Fine, all languages have grammar. So according to the grammar, you wish to know the structure of that. So you would to build a parse tree for that. Okay? And some sentences are really ambiguous and it's not so easy to build it. So it's still in the progressing phase. And then machine translation. Can you just let me know what Google Translator does? Most of you might be having mobiles, right? Who invented neural machine translation? You give the query, maybe sometime later to have fun, you'll definitely get a wrong answer for it. Okay? So maybe you wish to translate to some language from English. So all of you, I don't know how many of you use the Google Translator nowadays. But if at all you are traveling to a different place, you may make use of it. But they have really good progress they have made, but still there are some cases where they fail. Okay? And then information extraction. Here is a sentence: you are invited to our dinner party Friday, May 27 at 8:30. From this, suppose you wish to generate automatically a calendar task. Okay, add a task to your calendar automatically. You wish to build this app. Okay, when somebody sends you a message on WhatsApp based on the information in that, you wish to add some calendar event to yourself. So you need to extract, okay, when is it happening? It's on so-and-so date, on so-and-so weekday, fine. What is the event? It's some dinner party, at what time? So you need to extract all those information. Okay, that is information extraction. And one associated research area is open information extraction. People are building knowledge graphs by extracting information available on all web pages. Okay? And then the ones which are still really hard, one is question answering. Given a question, bringing out the answer. That's what to some extent ChatGPT is doing and even Google is doing. But still some of the questions are not even answerable by them. So it all depends on the knowledge base on which they were built or the language model on which they were built. Okay? There are sub tasks for this, like machine reading comprehension. It's just like the comprehension test that you should have taken in your language courses. Given a paragraph and some questions, you need to generate the answer from the paragraph. Okay, that's machine reading comprehension. That is a relatively easy task, especially for English. But for other languages like Telugu, it's not so easy because you don't have a lot of data to train your model. That's one reason. The other one is open domain question answering. That's what Google does for us. That you are not constrained to any paragraph or any document. You just pose any question, and the system should retrieve the answer. For this, the first phase is first you need to retrieve information. There is a course called information retrieval, if anybody is aware. So that would actually retrieve the information, and from the retrieved information you need to generate the answer. Okay, and generating the answer all the time may not be as simple as, okay, in the paragraph some sequence of words has to be given as the answer. That's the easiest thing to do. Sometimes you have to write an answer on your own, which is generating an answer, which is not so easy. Okay, just like how ChatGPT is generating the answer, in the same fashion you should be able to do. Then paraphrasing. How many of you use plagiarism checkers? Just raise your hands. Okay. So what is the purpose of paraphrasing? Actually, when we write any document, we should never copy anything from anyone. Okay, that's the best thing that we should be doing. But if somebody copies a sentence, the plagiarism checker is supposed to detect it, and all our submissions, like project reports, even for students or papers for the others, you should never copy from anywhere. Okay, you should understand what the other paper says, put it in your own words. Sometimes you may find like some sentence is really very important and it was written in the best possible way by the authors, but you want to rewrite it. It may not be so easy for you. So you can use some paraphrasing tool. Anybody knows some tools names? Yeah, Quillbot is one. So generate another sentence with the same meaning, but the structure of the sentence is changed. That is paraphrasing. This could be an interesting BTech project also. And then summarization. Even in a big document, we need to get a summary of it. Okay? How many people use this TLDR? Too long, didn't read. Which age are you living in? Come on guys. Students, you didn't use TLDR so far? Start using it. Let's say some new book is published. Let's say novel. Okay, you are very much fascinated by the author, you want to read, but you don't have time. You want to know what is the summary of it. You can just go and Google for TLDR of that book title, you'll get it. Not even that, maybe some textbook is there for you. You want to know the summary of that book or some chapter of that. You can use this summarization tools. Okay? And for this summarization also there are two kinds of things. Abstract chart application of any bank or any other company. And you find it to be really dumb, right? Okay? So whenever you pose a question, all the time the dialogue agent, the chart agent built for that website, all the time may not be doing a good job. Okay? And chat GPT is actually coming under this dialogue agent. Okay? So these are the applications and their status of implementations as of now. And why NLP is really considered to be a hard area to progress, and that's where you find many interesting problems to work on. The fundamental reason is there is a lot of ambiguity, like lexical, syntactical and semantical ambiguity, and then using some kind of, this metonymy means using some kind of figurative speech. Instead of using the person's name straight away, you may use some figurative speech. So identifying that is not so easy for machines. And then the complexity in representing and learning and using linguistic, situational, word or visual knowledge. This is the other challenge. Because whenever we use natural language, that's the reason why we don't write any program in language like Telugu or English, right? They are quite ambiguous. Fine. That's why we need a programming language. Fine. So many nuances that you use, idioms that you use, sarcasm that you use, and the context in which the same word may have different meanings. These all add to the complexity of handling text. Okay? One example here, two examples in fact. One is I made her duck. That's a very simple sentence, but you can get at least 5 meanings for it. And the other example is, this is again co-reference resolution example. Jane hit June and then she fell or ran. When you use fell, she would be referring to one of them. When you use ran, the other person would be referred to she here. Okay? So depending on what you put here, to whom she is referring will change completely. And I have just written some of the Meanings this text. Can anybody help me naming it? Great job at the rate so-and-so Justin Bieber. We're so proud of using some to whom they are referring or hashtags and some in capital letters and some newly coined spelling shortcuts and all. Okay, some emojis and so on. So this is non-standard English that you typically find on social media, and handling social media text is much more challenging than handling the text which is structured. Okay, and code mixed text is another where multiple languages, that's what we do when we type WhatsApp, Telugu words typically typed using Roman keyboard, right? Okay, they are all challenging. And sometimes segmentation issues, like you can see how New York could be segmented in different ways. And then idioms, okay? And then neologisms and world knowledge and tricky entity names. There are some interesting examples that you can refer to if you're interested. Now, why should we go for deep learning to handle NLP? Okay? NLP as a subject is existing since many decades, and I'm not talking about traditional NLP. Now we have something called modern NLP where we build only deep learning models for solving the problems. And the reasons for using deep learning, whenever you use a traditional ML models, machine learning models. I think everybody studied machine learning course, right? Yes? So you might have observed that, okay, you have some data on which you train a model and then use the model to predict, right? Now, whenever you are building a model, first thing is you need to have feature engineering. Fine? And for text, feature engineering is much more tricky. And compared to ML, deep learning models doesn't require any feature engineering. Deep learning is also known as representation learning, where the feature engineering is taken care by the deep learning model. So it learns the features, the best possible features, and deep learning models are suitable for text and speech and images, because for them identifying, like the previous professor was saying, attributes are your features. Identifying the attributes is not so easy. Designing the attributes is not so easy for these. Okay? We ourselves do not know what actually are the good attributes. So that's the reason why we should be using deep learning. So you can see that learned features, I am using that phrase learned features, because the features are automatically learned from the data. The only challenge for you is you need to have bulk amount of data and you need to have a lot of compute power which are available. That's also the reason for deep learning models are being so popular nowadays. Okay? So deep learning provides flexible and almost universal learnable framework. You can see visual and linguistic information. Okay? So you will be surprised when I present that ChatGPT learns in an unsupervised way. There's no one to tell it how to learn. Okay? So that's the power of deep learning. You can even learn from raw text in an unsupervised fashion, or let's say you are building a sentiment analysis model or spam filter, then you can learn in a supervised fashion. Supervised learning requires labeled data. For this text, what is the label? Okay? So, first thing, when you wish to use deep learning model, you need lot of data and lot of compute power. And of course, the deep learning technology has evolved a lot, at least from last 2 decades. There are so many new algorithms, new models that have been proposed. And because of all of these, the 3 reasons listed at the top, you find a lot of performance improvement, especially for speech and vision. Okay? So using deep learning for NLP is what we call as deep NLP, and this is a previous slide now. And some of the very popular models, okay, if you look at the state-of-the-art models for deep learning, you should start reading the slide from bottom up. Okay, The first one is for MNIST handwritten digit recognition dataset in 2010, and then speech recognition, followed by segment classification and then image recognition. And the 2012 is a milestone, very popular milestone, especially for NLP, that Nicolau paper for word embeddings, for language modeling, and Richard Socher, I think they have proposed embeddings. Followed by another very important milestone is transformer models in 2017. Nowadays, any NLP or image model that you build should be working with transformer models, nothing else. All the others are outdated. Don't even look at them, but you should look at them to know the conceptual basics. But when you are building anything for your project or for writing a paper, you should be starting from transformers. Okay? And now whatever that you see, like GPT based models or Dept based models, which we call as pre-trained language models. Okay? So they are the most recent advancement, that is 2019 and 20. Okay? And nowadays, if you see, there are some large language models. I don't know whether you have experienced Bloom, BLOOM, large language models, Llama, and there are many variants of them. But we cannot join such competition being academicians. Okay? So if you are well versed with transformer models, then you are done. You are good to go to do any project or research. Then a lot of application areas like image and speech that I have been telling. Okay, and anywhere you have a non-linear problem. Okay, and wherever you have a hierarchical structure, as identified by Jeff Hawkins, the world has a hierarchical structure, and I was telling you that deep learning models learn the features themselves, right? And they do it in a hierarchical fashion. The reason why they are able to do it is because the world itself has this hierarchical structure. And the last bullet is really interesting, like understanding the text or understanding the speech or recognizing an image or understanding an image is quite easy for us, but it is as of now difficult for machines to do. So that's the place where deep learning models are going to be useful. Okay, and all of you I think are very much familiar with shallow neural networks, which have very few number of layers. When you have many layers, we call them as deep learning models. Okay? What's the difference between these two is what this slide tells us. If you are having a shallow layer, neural network, the one on the right hand side in orange, and by the way, I think by now all of you know that a neural network model is universal learning machine or universal function approximator, which means given any problem, it will be able to model. What do you mean by function approximator? So whenever you talk about machine learning, you have input and you have an output. And this function is how this input is transformed by your model to generate the output. So that function is what we are learning actually in all these learning models. Okay? And to learn that function, what neural network can do is it can learn any kind of function. That's the meaning of it. But if you are having only a two-layer neural network, like the one on the right hand side, okay? Why am I calling it as a two-layer? You find three layers there. Why am I saying that it is two-layer? Come on. No. The first layer is the input layer and we never count it as a layer because its job is just to pass the input, right? Okay? So we have one hidden layer and one output neuron. That's why it is a two-layer. So a two-layer neural network can do anything. It can learn any function. But the problem is, in the hidden layer, you need to have exponentially large number of neurons. In contrast, look at the network on the left hand side. Okay? For both of them, input layer has only 4 neurons and output layer has only 1 neuron. But in between, for the deep learning model, I have smaller number of neurons at each hidden layer, but I have introduced many hidden layers. When I do like that, it can do wonders. Okay? So that's the reason why we wish to go for deep neural network. I'll tell you why adding more hidden layers gives you the benefit in the next slide. Yeah, you can take a look at this. It is easy to understand how this representation or feature learning happens for images. Now at the very bottom you find like some edge detectors. Okay? And using those edges, combining them, you have some small parts of the image being recognized. And in the next layer, you are actually recognizing the image that it is a dog. So this is how, when you have many hidden layers, in a hierarchical way, the model learns from very preliminary components to the required level of recognition. Fine? Then some brief, should I skip this? Everybody knows neural networks, right? Shall I skip this? Yes or no? Yes? Okay, I'm just skipping this. Now, the models that we use for NLP, first thing we use is recurrent neural network. Okay? The reason is, when I have shown you the neural networks earlier, I was showing there are 4 input neurons. If you consider a text, I may have a sentence of 10 words, sometimes a sentence of 5 words, sometimes I may have a very long sentence of some 20 words. So how many input neurons do you need? How do you know? Right? That's why we use a recurrent neural network where you will receive only one word at a time. Okay? It is unrolled over time. First word you receive in the first time instance, second word in the second time instance, but the knowledge of the first word is still maintained by your network in the weights. Then the third word and so on. So recurrent neural network relieve you from worrying about the length of the input. Okay? So that's the first one. And the recurrent neural network has a problem with them. When I have a very long sentence, or when I have a big document, okay, I may forget, my neural network may forget some information which is at the beginning of the sentence or the document, and that is vital at times. Let's say you wish to build a model whose job is to generate some program, let's assume, okay, or given some program you need to do some analysis. You may have some global variables declared at the beginning of the program, and sometime later at the 200th line you are referring it. When you use RNN, it will lose the knowledge over time. But that is important at times. So for that reason, actually they suffer from a problem called vanishing gradients and exploding gradients problem, because we are not having too technical discussion today. I am not getting into those. But LSTMs address that problem. Long short-term memory, they introduce the concept of a cell which has various gates to memorize or forget. And because of that, a very simple way you can understand is when you don't have a board here, right? So when you have a neural network, fundamentally the output is equal to some activation function of weight matrix into your input plus bias, right? Everybody knows it, right? Output equal to some function f of w x plus b. W is the weight matrix, x is the input vector, b is the bias vector. That's how a neural network functions. And when you have multiple layers, okay, this w, you pass the input, it gets multiplied by this, next again multiplied by the weights here, next again multiplied the weights, and so on. If these weights are very small, consider multiplying real numbers below 1. 0.01 into 0.01. What do you get? 10 power minus 4, which is much smaller than both. Okay? So when I have small numbers, when I multiply, they are diminishing. When I have large numbers, any value you take more than, greater than 1. Let's say one weight is 3, the other weight is 10. If I multiply 30, keeps on increasing. So, vanishing gradients, when your weights are smaller and you are doing repeated multiplication, they vanish. Exploding gradients, when I have larger weights, when I am multiplying, they become much larger. Okay, as simple as that. So, this product is now eliminated, and you will get a summation coming up when you use LSTM. That would remove the problems of RNNs. But when your input text is very lengthy, still LSTMs will also have a problem. To handle that, actually we have in the literature something called as attention models. You pay to some parts of your input which are more important. So that's attention. With LSTM and attention, there was a lot of improvement in the model's performance. And then you might be wondering why CNN is here when you talk about text. Because CNNs are meant for images, to extract features of the images. Whereas for text also, CNNs do a good job. You apply one-dimensional convolution over your text. Especially when you have spelling variations. Okay? When you have social media text where people write without a proper structure. When you use CNN, you will have a better performance. Okay? It's one-dimensional convolution. And then comes transformer models. Anybody knows why they are called transformers? Actually, the name is transformers. There is a comic called Transformers. Kids might be knowing it. Okay? Some super powers are there. One will have fire, the other one will have water, and some other who can travel from anywhere to other. Some superpowers are there. Okay? Like that, not one Superman or not one superpower. There are multiple superpowers involved here. That's why it is called Transformers actually. And I said attention is what people use to improve the performance of LSTM, right? Transformers, actually if you look at the paper title is attention is all you need. Okay, it says, okay, if you have attention, that's enough. You don't need anything else. That's the title of the paper. And they have used different kinds of attentions there, and then multiple times they use it. So it's called as multi-head attention. Okay? And transformers are the models which are really deep models. The simplest transformer has 8 layers. Okay? There are 12 layers or 16 layers. Those many layers they have. Okay? So these have shown lot of improvement in the performance. Believe me, from 2018 onwards or 19 onwards, whatever performance that NLP models are achieving are because of this technology. And then time transfer learning, which is like, okay, I learn from English. Then I would use my model to work for some other language. Okay, I have some knowledge of this sentence structure in English. I wish to use it for some other language. But across languages it's not that successful, but across domains it is. Okay, suppose I have built a model which can handle, let's say, New York Stock Exchange data, let's assume. Okay, then if I use it for BSE, our Sensex related data, it can work with little fine tuning of my data related with BSE Sensex. Okay, that is what we call as pre-trained fine tune. Okay, so these models are initially trained on large amount of data. And the model parameters. What do you mean by model parameters? The weights and biases. Okay? They are learned. And using them as a starting point, it is a small amount of data that you need for your own problem. With a small amount of data, you can fine tune that problem. So, this is a very catchy term since last 2-3 years. And all models that you see nowadays are actually fine tuned models. Nobody is doing pre-training. Okay? And large language models, as I said, they are beyond our reachability. They have trillions of parameters. They need a lot of memory. What we can do with them is, we can only generate some prompt and extract information from them. You might be seeing YouTube advertisements like prompt engineering, all that, right? So they are like, I have a large language model. I give my input in such a manner that for the required task, it gives me the meaningful output. How do I give the input? Okay. Those who are interested, you can read a paper on T5. T5. I think I have it in the resources. And this is the timeline as I was telling. Okay, the first neural language model. Recently, Jeffrey Hinton was advocating, okay, AI research should be put on some video by, I think, I don't remember the name. He's from Microsoft, and the real competition among countries doesn't exist any longer, actually. Who is dictating your future, by the way? One such dictator nowadays is Google, the other one is Facebook. Okay? Earlier, like Second World War, like bipolar world, like Russia and Americans are two ends of the world competition. Later, China, America. Now it is between tech giants. It's no longer between countries. Okay? Okay, 13M, you can see the vocabulary strength there. Okay? Now, what's the problem with the one there? Blue top, bottom two vectors. They are actually related words, motel and hotel. All of us know it. Isn't it? But if you take the dot product between them, which is fundamentally what you use when you do cosine similarity. Cosine similarity measures the angle between two vectors. When you are representing text, they are vectors. So to know the similarity between them, similarity between words, you need to find cosine similarity. Cosine similarity is only taking angle. Okay? So cosine similarity is defined like dot product divided by the magnitude of the vectors. And if you compute the cosine similarity, it is 0 because dot product is 0. And if you consider the Euclidean distance is in the space, the magnitude of the distance between them, right? Fine? And that is the same. That means both words are equidistant. That's what it says. Between cat, dog and truck. How can you agree? Cat and dog are animals, whereas truck is something else. How can they all be of the same distance? When you have this kind of a problem, when all words appear to be equally distant, suppose you are doing some similarity based data mining algorithm. One popular one is k-means. You compute distance between the elements to group, right? Now all of them appear to be equidistant. Do you perform clustering now? Obviously no. Are you all sleeping? Are you understanding now the difficulty with one-hot vectors? Now typically I give this example to my students. Whenever you talk about cluster of dimensionality or highly sparse, large sized vectors, imagine a decoder. You know encoder and decoder, right? I have my friend, let's say she is my friend, and somehow I quarrel with her. Somehow. Okay? So I want to tell something to her, but she should not understand. Then what do? I do encoding. Like in this James Bond movies. I will speak to her in some language which she doesn't understand. And she will decode it. We have some coding mechanism, okay? So she understood how to decode it and understand the actual sentence. Because she doesn't know how I have transformed my original text, she cannot decipher it. That's simply encoding and decoding. Now, we have our input text, let's say in English. We observe the relationships between the words, okay? And we arrive at embedding vectors for every word. That's the job of the encoder. Okay? Now, these embedding vectors, as human beings, if you look at, do we understand anything? No. I showed you some vector for banking. Some real numbers are there, some positive, negative numbers are there. What do you understand from those numbers? You cannot understand, right? So that's the output of the encoder, which is the representation of the words. Using that representation now, let's say I am doing neural machine translation. I have given the input in English, I want the output in Telugu. This is my task. Now from these embedding vectors, Telugu words have to be generated. In order to do that, I need some machinery now. And again, what am I using? Similar kind of architecture, but some new things added here. On the above, you find something new, right? Remaining all are the same. So this right hand side part is called decoder. So a transformer model is composed of encoder model, whose job is to learn the embedding vectors. Decoder, which uses the embedding vectors and generates output for us. Okay? Here also you have positional embedding and then this masked multi-head attention, many things. And you have something called as cross attention here. You find some line coming from the encoder to the decoder. Do you find it? This line. Okay, that is moving from encoder to decoder, and that gives you something called as cross attention. Okay. Now for neural machine translation, what will I give as input to my decoder in this particular example? I would only say start generating the output. Nothing else is given as input. My English sentence is given as input to encoder. For decoder, I will say start generating the output. That's it. Okay. For some other applications, you have text given as input. So when it does all of this, I said my embedding vectors have some dimensionality, right? Yes or no? For this transformer models, it is conventionally 768. Every word is represented as a 768 real vector. My decoder also outputs a 768 vector. Let's say I am translating to Telugu. Telugu, let us assume the vocabulary of size 5000 words. Let us assume. Now, in order to generate the output, I need to generate a 5000 dimensional probability vector with highest probability for the word that I wish to output as the first word. So from 768 dimensional vector to 5000 vector, I need to do some transformation. How do I change a vector dimensionality from 768 to 5000? I involve one matrix multiplication there. 768 by 5000 sized, that's the dimensionality of my matrix. Input is a vector of 768. I think we have a board. We have a pen here. Chalk. Robota is superior in terms of performance of Dept. Dept uses actually only encoder of transformer architecture. That means only the left hand side part. Only takes the contextual embedding vectors. And it learns in a self-supervised manner. That means no label training data is available. I'll take all Wikipedia dump. That's one resource. All Wikipedia articles. Books corpus. I will feed my input with something called as masked language modeling, which means I have a sentence with me in some Wikipedia page. These are my words, let us assume. I will mask this word at, I know, because I know the actual sequence of words. So this is called masked language modeling, MLM. Now in order to do this, do I need any training data for my model which is human labeled, which is costly to get? No. I am just taking some documents available online. I am predicting that okay, some words are not known to me and ask my model to predict. Okay? So with this, I can train my model on large corpus of data. That's what ChatGPT is also trained on. Okay? That's how. All documents available on the internet are used to train the model. But what you need is computing power and memory. Then another training objective for this is, I know the entire Wikipedia article, right? I know the first sentence and I know the second sentence. Sometimes I will give the actual second sentence and I will ask my model, is this the next sentence following the first sentence. It should say yes. Sometimes I would replace this sentence with some random sentence, and I'll ask my model, is this sentence the next sentence of the first one? It should say no. If it fails, there is some loss. I need to minimize the loss. I train my model parameters. Okay? So those are the learning objectives, and they use something called as word piece tokenizer. So far, whenever we have a sentence, taking the space as the separator, we tokenize the words. Every word is an individual unit. But if I use like this, some new words that are coined, unfriend, okay, retweet, or some new spelling that students use, they write their own spellings, right? These are all out of vocabulary words. They are not the conventional words. So in such cases, to understand the new coming words also as the language evolves, I take only sub-parts of the words which are commonly occurring. That is done with the help of word piece tokenizer. All of these are library functions. You don't need to do anything. Just call the function and use it. Okay? So I'll show you some. I don't think we have time to look at the code, but I'll share some notebooks with you to take a look. And Robota is an improvement where they determine that okay, this next sentence prediction is not that useful. They are the parameters of the model. Right? So, yeah, this lot of criticism is there on neural network based models because you don't know what's happening inside. Okay, they are called as black box models for that. So, once the model is built, what madam is asking is, let's consider the question, the topic that the previous professor has taken. You need to predict whether a student gets placement or not. Yes or no, you are giving the input. Let's say your model is something like decision tree. You would have a question, what is the academic performance, CGPA or percentage of marks? First question is that. Greater than 80 or not, let's say, that's the first question. If it is less than 80, you come to left, let us assume, greater than 80, you go to right. And then you have another question, communication skills, good or bad, okay, like that. So when you have this tree can be transformed into if then else rules. So you know like what is actually happening when you give an input, based on which you understand how the model is determining the output. In contrast to that, when you have deep learning models, you don't have anything as such. Why for this input so and so output has come? You don't know. What you understand from the model behavior is, or model knowledge that you have is, okay, what are the weight values and what are the bias values. Okay, first layer, what are the weights? Second layer, what are the weights? That's all. You're just having some numbers with you. That's it. Using that numbers, we can't understand anything, right? Okay. So there is something called as interpretable AI or interpretable machine learning, which has some models like line integrated gradient, and some models use attention scores also, which tell you which part of the input is the reason for getting this output. Let's say you are given text as input. So-and-so word or so-and-so phrase is the reason for generating this output. So they would give this kind of information. So it is called interpretable ML. Okay? But you cannot understand the model per se just like a decision tree.